All right, so we've made it quite a ways so far, taking a look at how to develop shaders inside of RenderMonkey. Now it's time to get these shaders into our own custom application.
That's right. I mean, that's where we're really going to be needing them.
Obviously, and that's where things get a little interesting. Now we're dealing with two different languages, and how do we make everything communicate back and forth, or, well, just forward? So anyways, what we're going to do in this video is show you a linear approach to taking the shaders that we've written over in RenderMonkey and have them apply to our geometry inside our own application.
Right.
Now, this is all fine and dandy if you're dealing with just one shader, or maybe even two shaders. But at the moment you've got 3, 4, 5, or more shaders, you're going to want to come up with some other implementation.
Yep.
And we're going to do that in the next video. What we'll do is we'll create a shader class,
right,
which will allow us to treat our shaders as if they were objects.
Right. In this initial implementation, we just want you to see all the steps necessary to creating a shader inside of C++ so that you can use them.
Precisely.
And once we understand how that works, then we can move on and actually make it more usable.
Right. Now, before we start coding, let's go ahead and advance to the next slide. Let's talk about the steps required. Just a very general overview, if you will.
Right. So the first thing we need to do is get the source code into our application, and that means from RenderMonkey into our own C++ application.
Right.
We need to actually create a frag and vert file. From that point, we create our Vertex and Fragment shaders, and this is with a few OpenGL function calls, GL create shader object, and then we create both of those. And once we get that done, we need to actually physically read those files into a character array.
Okay.
And once we get that information, we can call another OpenGL function call called GL shader source, and we pass to those character arrays, and then it will actually put that and associate it with those handles. Okay. That was returned from our GL create shader. And once we get that, we're going to compile the shaders. And then once we're done with that, we can create a program. And a program is essentially something that holds a vertex and fragment shader. And once we have that, we attach the two objects to it. So we attach both shaders, the vertex and fragment shader, to the program, and then we need to link it. Much like when we're linking C++ programs, we have a compile and link stage. Same idea here. Once we've compiled each of the shaders, we need to link them together inside of our program.
That's right. Now, if you are still relatively new to the world of C++ programming, and you're going through this, and you're new to the whole shading idea, some of the things Joel just said may have put the wrong image in your head. Mm-hmm. Like, compile the shaders. You may be picturing hitting the compile button back over in RenderMonkey for whatever reason, or the linking. Every single thing you see starting there at step 2, basically after the copy and paste shader source code, everything is done code-wise in our application. Right. That is what you need to understand.
Precisely. So let me go ahead and switch over into my Visual Studio real quick here. So what we need to do is create two files, one for our vert and one for our fragment shader.
Now, as a quick note, right before Joel begins programming, if you skip the last video and you don't have glue set up on your machine, please go back and watch that video. Right. You'll recall at the end of it, we had glue set up as an include and a define as well, so that it's linked statically. Please make sure you do that.
Right.
Okay.
So let me go ahead and go down to my resource file section here, and this is just a folder where I'm going to throw in both of my resource files, my fragment shaders and my vertex shader. So let me just add a new item here, and let me just call this, let's see, what do I want to call it? Lambert.vert.
Okay.
So let me go ahead and add this in here. So I have my Lambert.vert, and I'm going to also add my Lambert.frag. So we have both of these, our vertex and fragment shaders. So let's go into RenderMonkey and get those two source codes. So if we go back into our preview window, this is what we have. As a quick
reminder, we took that second light out.
Right. And now we have just a simple light where we can modify this, and it moves the light around. And what our goal is to get this working inside of our own application.
Right.
So let me go over to our custom shader here. And this is the vertex program. So let me just copy this. Come back over into Visual Studio here, and this is the vertex one, so .vert. Just paste this in here. Notice no syntax highlighting or anything, but remember, in Visual Studio, we have already debugged and compiled and made sure that our shaders work properly inside of RenderMonkey, and here the only task is to get it into files that we can manage and use inside of our applications. So let's save this out, go over to Lambert.frag. Now let's switch back over into RenderMonkey, get our fragment program, Control-A, Control-C, go back over into Visual Studio, and paste this in here. So now we have our vert and our frag.
Okay.
And at this point, we can start coding and start getting everything prepared. So the first thing we're going to need to do is hold all the information. As I mentioned before, we're going to create 3 things: Vertex program, a Vertex shader, our Fragment shader, and our program. And all 3 of these have a handle to them. So we're going to have to store those handles so that we can access them at a later point. And to do that, we have a GL handle ARB. And we're going to have our Vertex, our Fragment shader, and our program, which holds both.
Right.
And once we have those, we can switch back down over into our init.gl, and this is where we're going to initialize our Fragment shaders. So the first thing we need to do is initialize glue, and then see whether or not Vertex shaders are even supported.
Right.
So we'll do a glue init, and be very careful to initialize glue first. Otherwise, if you call functions that are inside of glue, they will lock. It will lock your program, and you'll get unpredictable results. So the first thing we're going to do is see if Vertex shaders and Fragment shaders are even supported. So we'll do a glue ARB Vertex shader and glue ARB Fragment shader. And if this passes, then not supported. Right?
Right.
Let me just run this real quick here. And let me just run through this real quick so that you can see exactly. Actually, let me break out of that real quick. Since I'm not doing anything, it simply skips over that line. Let me do something really funny. Let me just some function line that I can get to here with. And depending on what you want to do with your application, I mean, if you require shaders to make your program work at all, then you might just want to exit the program.
Exactly.
So if we come into here, it gets into here, dink. I think I might have said this opposite. If these 2 pass, then it will work.
Right.
So let me just stop that debugging. So we can put inside of here, it works fine, right?
Right.
And you can handle it inversely if you want. So you could put this in parentheses and say not.
Or we could just take the not out and wrap all our code up that comes next inside that. In fact, let's just do that.
Okay, we can do that.
It just makes the most sense.
It does.
I'm glad you did that, because I was sitting here thinking to myself, all right, that
doesn't make sense.
Yeah, it doesn't make sense. It seems backwards.
I was just so involved in typing.
I gotcha. Okay.
So inside of here, the first thing we need to do is create our shader objects. So we have 2 shader objects, our Vertex shader object and our Fragment shader object.
But before we create those, let's go ahead and just put an else real quick and put some comments in there.
Sure.
Say, do something because this is not supported.
Vertex shaders
not supported. And
not supported.
That's good enough. Yeah.
Yeah, and of course Fragment shaders not supported.
Exactly.
So inside of here, what we're going to do is create our shader objects. Thank you for pointing that out. So we have our GL create shader object ARB, and we're going to pass it what kind of object we want to create. So our GL Vertex shader ARB, and F equals the same thing.
Yeah, same exact thing.
Except for the last part here, which
needs
to be
GL
Fragment.
Fragment shader ARB. Nice.
So there you go. So we've created it. Now what we need to do is read in our files so that we can actually go ahead and compile them. So to do this, we're going to create 2 local variables, a constant, just a VV, just to specify the file. So read in a file.
This is a function that we'll create in just a minute. We need some sort of function that's going to accommodate reading in the data from those files.
Right. Basically, we need to open up the Vertex shader, put all of this data into this character array here. And read file, the function is going to allocate that memory
and
for us.
And obviously the argument that it would accept would simply be the file name. So let's just go ahead and give it to it.
And we'll create this actual function after we're done here.
Yeah.
This kind of blocks everything in for us. And then this is going to just be our FF, and this is going to be our Fragment shader. So there you go. So once we have this, let's make sure these 2 aren't null, because if these 2 files don't exist, we obviously can't continue. So we can simply say if VV does not equal null, and FF does not equal null, then let's go ahead and set those up with our GL shader source, as I mentioned in the PowerPoint presentation. So GL shader source ARB, basically this is associating this particular file with our handle that was passed to us via create shader object.
Right, meaning the first thing we need to do is give it the handle.
Exactly. And then and then we need to pass it the address of our file, the data for our file.
All of our data, that's right.
So then we just copy this for the same one. So F And this is going to be FF, so again, the address of the information.
Cool.
And then at this point, we've already associated it, so we can go ahead and delete this information out. So delete VV and delete FF.
Okay.
So it deletes that information out. So at this point, if I just switch over into the PowerPoint presentation really quick here.
We've made it all the way down to associate character array data with the created object.
Now we need to go ahead and compile them.
Right.
So let me go ahead and switch back over in here and simply do a GL compile shader ARB and simply pass it the handle. So for our Vertex shader, then for our Fragment shader. And then at this point, we need to create our object, switching back into PowerPoint real quick here. So we've just compiled the shaders. And again, as Buzz mentioned a second ago, what we're doing here is everything is done inside of code at runtime. So we load in the files, we compile it right before our application starts, and then we create the program and do the linking. So all of this is done at runtime.
But here comes the beauty of doing that. Now we can go and change our shaders up without having to recompile our application every time.
That's right.
And that's nice.
Very nice. So if we come back over into here, let's go ahead and create our object. So P equals GL create program object, ARB. And we need to attach these objects, Vertex shader and Fragment shader, to our program. So do a GL attach object, ARB. Pass it the program handle.
The program, and then pass it the
Vertex handle.
Exactly.
And then our Fragment handle as well. And if we come back over in here real quick, finally, we've attached both shaders to the program that we've created. Now we need to link the program. Very simple. Simply do a GL link program ARB and pass it P. Now at this stage, we have everything we need.
And here's a better way to put it. We're now set up.
We are set up.
We're set up with our shader. We're just not using it at the moment.
Exactly. So before I continue, there are a few more things we need to do. But I'm going to go ahead and implement the read file. And we're going to come back here and set up a few attributes that we set up previously.
Sure.
Because remember, in RenderMonkey, we had the artist-controlled variables that was set where the light position was, the diffuse, the ambient, etc. And now there is no longer an interface to allow us to manually modify that.
Right.
We need to actually call functions that will set up those properties for us.
That's right.
So right before the initialization of OpenGL, I'll create another function that does my file manipulation, or reading of the file. So I'm going to return a pointer to a character, because that's what's going to hold all the information. This is going to be called read file, and we'll pass it the file name. And inside of here, we need the length of our file. So this is going to store the length of our file. We're also going to store the information that we get. So we'll just put that in a buffer. Buffer. Now we're going to use ifstream as we did back in the OBJ loader.
Exactly.
So ifstream file. Let's go ahead and open the file up with it file.open. Pass it the file name. And we're going to open it up as binary just in case there is anything inside of there that's non-compatible or whatever. So open that up. If it didn't work, simply return no. So file.isOpen is not true. Return no. And then what we're going to do is seek to the end so we can get the length. So do a seek G, starting from the beginning and going all the way to the end. And then we can simply get the length by saying, okay, where are we inside the file? So file.tellg. And there we go, we have the length. But now we need to read the data back in, so we need to go back, seek back to the beginning. So do a file.seek to the beginning, so file.seekg, and go to the beginning, so pass it 0, and stdios bg. At this point, I know how long the file is, so I need to go ahead and allocate that memory. So buffer equals new car length. Allocated it. Now let's go ahead and read the information in. Simply pass it our buffer and how many characters we want to read in.
Right.
And then finally, what we need to do is close the file.
Okay.
And we need to return the buffer.
Right.
So there we go. And again, remember, since we have read our character and we're allocating new memory here, so once we're done with calling read file, we need to make sure to delete that memory later after we're done using it.
Right.
So back here, if we go back to here, remember, we are deleting it, so everything is good. Okay, so at this point, that's set up. Now, let me go back into RenderMonkey real quick here. So what do we need to set up? Well, we need to set up a texture. We need to actually set our cloud texture variable here, which is a uniform sampler, and we need to set what that value is so it knows which texture to use for our cube.
Precisely.
And we also need to set up the diffuse color, the ambient color, and the light position. So if I go back over into Visual Studio here, right after the program link, what I'm going to do is add in some methods, to set those properties up. So how do we get the texture or the property that we need to modify? Well, basically, there is a function called GL get uniform location ARB. And what you do is you pass it the program that you're looking for, and you pass it the attribute. Let's say in this case it's cloud texture. And what this is going to do is return an integer that's an index into the array, if you will, of properties that we have to access. And in this case, as it says, get uniform. So these are the global variables that we're allowed to change.
Okay.
So once we get that, there's another function that allows us to modify that particular attribute, and that's GL uniform, and there's 1i, which means one integer, ARB. And of course we have 3f, which means 3 floats, 4f, which means 4 floats, etc. And the first argument, to the function is the index, which attribute we want to modify, and then we simply pass the value that we want to change it to. So in this case, it needs to be an integer. Well, we want it to be the first texture that we find. And this is a little bit different than the bind texture, GL bind texture that we used before, where it has the text ID. This is saying which texture unit to use. So when you do a bind texture, it's going to automatically assign it to texture unit 0. If you had multiple textures you would want to use, you set them to different texture units, and it would work properly. And we'll see this as we go. So next, let's go ahead and copy and paste this so that we can set up the rest of our arguments, our uniform global variables. And this is going to be our ambient. And let's go ahead and set the default ambient to 0.4f, 0.4f, and 0.4f.
Just so that any area that's not in light's not completely black.
Exactly. Let me just go ahead and copy and paste this for diffuse. And
let's give it a little bit of a red tint.
All right, just so that we
can see it.
Yeah.
And tell that it's not
exactly
using the vertex, because it's not using the legacy path.
Yes, exactly. Have fancy terminology there. So right here we also need to set our light position, so FV light position. But remember, this is a 3 float, a vec 3. So this needs to be changed over from 4F to 3F. And let's see, what kind of default light position do we want to have here? Actually, if we come back up to here, notice this is no longer going to be used for our main light.
Precisely.
I could use these values, but I tested some other values that kind of worked a little bit better. So I'm just going to throw these guys in. So 50.3F, 18.9. Something like that.
And you can see where, at this point right here, if you wanted to have simulated lights out in your application, you can start associating that data with this here.
Right.
Basically, you could go and set up several different lights inside your shader.
Right.
And then have those populated. If the user decides to put lights in their scene, otherwise those lights just wouldn't influence the shader at all.
Right.
But they would be available in the shader if need be.
Exactly. So we've set that up. Now we need to actually go ahead and use this, because remember, at this point, it's saying, excuse me, we're going to use this program object. We need to say, all right, we've linked the program. There's no code that actually says stop using legacy and start using our shader.
That's right.
So there's another function call that we can use called GL use program object ARB, and we simply pass it P, our program handle. And at this point, it's going to start using that program. But keep this in mind. When we're changing these attributes around, you need to have it already using a particular shader. Otherwise, it doesn't know which global variables it's modifying.
That's right.
Because when you have many, many different programs, how is it going to know which program you're referring to?
Right.
So set that up. And if you want to disable and return to legacy, simply pass null over to use program object ARB. So at this point, all we need to do is go over into our draw cube and set it up. So if we go into our draw cube here, first off, we need to start using our program object. So do a GL use program object. Remember, we have two things. Our floor, which we want to use the legacy method for.
That's right.
And we have our cube, which we want to use our new program method, our new shader, if you will. So program object ARB, pass it P, and GL bind texture with this. Now, as I was mentioning before, you can set which texture unit you want to use. To do this, we can say GL active texture ARB and pass it which texture unit we want to be modifying. So ARB, by default, it is modifying the first or 0 element texture. But if you had multiple ones that you needed to set up, let's say you had a diffuse map, a specular map, a normal map, etc., you would want to be able to set different texture units. So you could change this to 0, 1, 2, 3, or whatever.
Exactly.
In this case, we only have one, so we'll set it to texture 0 ARB. And then we'll simply enable textures for this particular texture unit. So GL texture 2D in case someone disabled it for some reason. And then after we're done drawing the cube, we need to come down and disable it. So go back to legacy method. So GL use program object ARB and pass it null.
That way only our cube is going to have the shader applied and the floor's not.
Right. So let me make sure. Okay. 3F ARB, I'm passing it a 1 at the end. So let me just delete that out.
Okay.
Let me compile this. All right. So it seems to be everything's working okay. Now the big test, running it. Ooh, look at this.
Very nice.
If we zoom in, notice it has a red tint on the object
Because
here.
Buzz said make it red.
That's right.
Just so that we can tell.
Exactly. And if we wanted to return to the legacy type, I mean, we could do a variety of things. If we come down to our draw cube, we can simply pass this null, and then it's never going to get set.
Which means now it should not have a red tint.
Right. So now it's having
Look at that. Just vertex lighting, vertex coloring, the legacy path, and the rendering pipeline.
Exactly. So let's just turn this back and compile it one more time. Run it.
So the cube is now being shaded by both a vertex shader and a fragment shader. And the floor is being shaded by the old-fashioned way.
Exactly.
Combination of the two. And we're still using anti-aliasing and our little reflection trick, if I can talk. There we go. So, again, a linear approach in a way.
Right. This is not really extendable. If you had 30 shaders.
Oh, it would be a nightmare.
It would be a total nightmare because you would have to, for every single one of those shaders, you would have to call use program object, create program object, compile, link program. It's just all sorts of trouble.
So to simplify things, in the next video, what we're going to do is create a shader class that you guys can add to your collection of cool classes, utility classes. And this will allow us to manage numerous shaders easily. We're going to step back into the world of object-oriented programming now.
That's right.
Okay, so that's going to pretty much wrap it up for this video. Thanks a lot.